now that I've showed you all that, okay, go ahead and put this matrix, that pink matrix, into your calculator under like A. Got it? Oh, wait, Vivian's still working on it.
Oh, no, I was making
You got it?
plug
Okay, now, get out of the matrix thing, okay, so do second quit, and then get back into it, okay? So then select matrix, go over to where it says math, see the math button under the matrix thing? See the first one down where it says determinant? Hit enter on that, and then go back and select the matrix that you just put that in for, and then hit enter. And you're like, why in the world did we just do all we did? Because sometimes you've got to use matrix without calculators. Okay, so you have to know how to do it by hand.
When?
ACT, SAT, you'll have some stuff like that maybe on this section which says no calculator use on it, to see if you know how to do it. Pay attention on the ACT and the SAT whether they're parallel lines, because if they're parallel lines and you see it, it means find the determinant of it, which is what we just did. Okay, it's not going to say find the determinant, it's going to give you something like that, and it's going to expect you to know how to do it. So those parallel lines, not that have the feet and the shoulders, which is not a very technical term, but you get the concept. If it has those parallel lines, then what it's saying is find the determinant of it, okay? So, I'm going to turn around. Now, all we did was we did second order and we did third order. If you've got a fourth order determinant, you're going to have to use your calculator, okay? Because you have not learned, nor are they going to teach you how to find by hand the fourth order determinant. To find a determinant of something, it has to be a square, okay? So it has to be a 2 by 2, a 3 by 3, a 4 by 4. You can't have a 4 by 6 and find the determinant of it. If they give you one and they ask you to find the determinant of it, the answer is not possible, okay? Now we're going to talk about inverse matrices, okay? And I think you'll remember some of this. You won't remember the details of this because we never capitalized on it. Okay, remember the identity theorem that says if I multiply 5 times 1, I get 5? Well, there is an identity matrix. So if I have a matrix, now see that I'm back with the shoulders and feet again. So I have a 4, a 2, a 0, and a 1. There is a matrix that I am going to multiply it by to get itself. Okay, this is what we call the identity matrix, or I. Okay, you with me? The identity matrix is that. I think you might remember that. If I have a third order, then I just have diagonal ones and I have 0 everywhere else. If I put those two in my calculator, I could make you do it by hand, okay, which would be a bad idea, okay. So 4 times 1 is 4, plus 2 times 0 is 0. 4 times 0 is 0, plus 2 times 1 is 2. Then the next column, 0 times 1 is 0. 1 times 0 is 0. And then over here, I have 0 times 0 is 0. And 1 times 1 is 1, which is going to give me 4, 2, 0, and 1. Okay? So your identity matrix is always the diagonal ones plus zeros everywhere else. Okay? In the same sense, we have to be able to find the inverse matrix. So up here, if you remember right, multiplicative inverse, if I multiply 5 times 1/5, it's going to give me 1. Okay? So this is what we call the inverse of that. So there also has to be a matrix that I can multiply by this, and it gives me my identity matrix. Just like when I multiply this times this, it gives me the 1. Okay? You with me so far? All right, so how do I find this inverse matrix? Okay, if I call this matrix A, this is what I call the inverse of matrix A. Well, there's a pattern. I'm hoping you'll remember the pattern. You may not remember the pattern. Okay, the pattern does this. Now, this is just with a second order matrix. It's 1 over the determinant of that. So 4, 0, 2, 1 times, I'm going to switch these two, 1, 4, and take the opposite of those two. Okay, so far so good? Okay, got to find the determinant here. So 1 times 4 is 4. 2 times 0 is 0, so it's 4 minus 0. So this whole thing becomes 1/4. Okay, you with me? Because the determinant of this is 4. So I'm going to take 1/4, I'm going to multiply it by each one of those. So I have 1/4, negative 1/2, okay, because 1/2 times negative 2, 0, and that's going to give me a 1. So guess what? If I put this in here, and I did it on my calculator and multiplied this times this, it would give me the identity matrix. This is the inverse matrix of that. Y'all remember doing that? Kind of, sort of. You probably remember the idea that you switch the two and take the opposite down here. Let's try another one. You don't remember that. Here's the problem. We never built on it. It was just one, and that lets you know the stuff that you remember is the stuff that you continually use. Yeah,
like going really
yeah,
hard.
and then we never had it again.
Yeah.
We literally never touched it again. And I hate to tell you, but the same thing's gonna be true this year too. Okay, you hit it and that's it. Now, there is application to it. I'm gonna show you the application. And if we could remember the matrix enough to do this, we were like, oh man, it makes life so much easier. But the problem is we don't remember the matrix. So let me, let's do this one. Okay, we want to try and find the inverse of this matrix. So I'm looking for the inverse matrix. And what I mean by that is I am looking for the matrix that I can multiply it by to get the identity matrix. Okay, now the pattern with how I find this is what I just did. Okay, we're going to do this one together and then I'm going to give you one to do. Okay, 1 over, and then it's going to be the determinant of this. Now, this would be a good time for me to tell you, sometimes you can say the inverse matrix doesn't exist. Because if I get a 0 answer here as a determinant, I can't have 1 over 0. So then the whole thing is undefined. Okay, so what I'm doing is I'm finding the determinant of that. Notice that my shoulders and feet just became 2 parallel lines. Yes?
Camera.
Did it just click off?
Yeah. Pretty sure it made a noise.
All right. Times, okay, then the pattern that works, I switch these two. So the -1 comes up here, the 8 comes down here. Then I take the opposite of those two. So if they're positive, they become negative. If they're negative, they become positive. Now literally the only thing I'm using that for is I'm multiplying whatever I get here by it. So the big thing is finding the determinant. So I have 1 times negative, or 8 times -1, which is -8, minus my 27. So this is going to give me a -35. So I am going to multiply negative 1/35 times that. So that's gonna give me positive 1/35. That's gonna give me positive 9/35. That's gonna give me positive 3/35. And that's gonna give me positive, or negative 8/35. Okay? Now, does that make sense? Okay? Take your calculators out, put that matrices in it.
Put the first one. up
Just
there. Okay.
this one. Got it? All right, now select that matrix and then go to your calculator and hit that button, x to the negative first power, and hit enter.
Wait, what? Wait.
Select this matrix.
Okay.
Okay, and then press this button. Now, does it give it to you in decimals? Okay, hit math, hit your fraction button, hit enter, and hit enter again, and it should put it in fraction form.
Okay, you want it in fraction form.
Mm-hmm. Did you get it?
I think so. Oh, wait, no. Wait, okay, how do you put in fraction form again?
Okay, math. Oh, wait a minute. No, you hit the wrong button.
Oh.
Okay, so matrix
Oh, I did.
A, this button, x to the negative first.
Yeah.
Okay, now it's gonna give it to you on all those kind of fractions. No wonder you were looking at us like strange. Okay, now go to math, hit enter under the fraction, hit enter again, and it'll put it back in that one. Okay, now, I need you to do one by hand though, okay? All right, I want you to find the inverse of this matrix. Not using your calculators. Make that clear. No? Did you switch the 7 and the negative 2?
I got -1 when I did that.
Oh.
You got -1 when you did what? This?
Mm-hmm.
Did you subtract?
I had a positive 14.
Okay, because that's a -2,
Mm-hmm.
which makes that a -14. That would change it.
It was really easy.
Yeah, I bet it was. Get it?
Not that fast. How did you guys get that fast?
Okay, so what do we use this for? Okay, that would be the big question.
Well, I do understand.
Okay, now I will tell you to find the inverse of a third order matrix, you're just going to use your calculator. The only thing that they taught you how to do was to find the inverse of the second order matrix. And that's the only thing they taught you in Algebra 2 how to do. So, yes, there's a way to do it on a third order, but they're not going to expect you to know it. okay? So if you have a third order, you're simply gonna put it in your calculator. And that's what we're going to, well, I think I'll show it to you first with a second order. This stuff is used to solve system of equations. And this is actually pretty cool. And it might not be worth it for something like that. You might use elimination, you might use substitution. But it becomes worth it when you're solving for X, Y, and Z. But if I go to do this, I am going to set up a matrix. So I have 2, I have 1, I have 3, and I have -1, using their coefficients. Times X and Y. Okay, because literally if I multiply these together, I'm going to get this. Okay, is equal to -17 and 4. Okay? Now, just like if I had 2x equals 12, how would I solve for the x? I would divide, or I would take the inverse of the 2. So I would basically say 1/2 times 12, which is the same thing as dividing. This right here is the inverse. So I can solve for the x and the y if I take the inverse of this matrix and multiply it by that. Now the inverse of this matrix is going to be a 2 by 2, right? That's a 2 by 1. So I have to put the inverse first before I multiply by that. Remember, the middle numbers have to match. So I'm going to do the inverse right here. Now, I'm going to do it by hand, but understand this can be done on a calculator. So I have 1 over the absolute, or the